Thank you. So the next talk is Dr. Peter Wing from the University of Oxford, Visualising the Interplay between Coronavirus Replication and the Cellular Hypoxic Response.
Fantastic, thank you very much. So I'm Pete, I'm a very baby junior PI at the University of Oxford. And what I want to talk to you about today is my work on looking at how virus infections affect cellular homeostasis from the point of view of how cells utilize molecular oxygen. So I think we can all appreciate in this room that viruses and a cell sort of maintain a homeostatic balance. And viruses are sort of experts at disrupting or manipulating this balance for their own nefarious purposes. Now, cellular homeostasis means a huge amount of things, but what I'm focusing on is how cells utilize and detect molecular oxygen. It does this via an ancient transcriptional cascade, which is unique throughout, which is common throughout all life on this planet, and essentially it's switched on when oxygen demand exceeds supply. And the work I've done as sort of my postdoc, mentored by Professor Jane McKeating, demonstrated activation of this pathway potently inhibits SARS-CoV-2 and the rest of the coronavirus family. Now, the work that my group, my sort of young group in a way are looking at is actually flipping this question on its head. Instead of looking at how the hypoxic response affects viral replication, we're looking at how viruses affect the ability of a cell to respond to variable levels of molecular oxygen. The way we've done that is by using high resolution imaging, using X-ray tomography at diamond light source to look at the cellular ultrastructure of coronavirus infected cells combined with high resolution imaging of using SM fish. And what we detected using this technique is significant differences in cellular ultrastructure in infected cells with different levels of molecular oxygen. Finally, we've also been using hypoxic reporter cells, which very simply, when they haven't got any oxygen, they turn green. And what we then determined was when these cells are infected, they can no longer respond to low levels of molecular oxygen. And we've also shown that with the transcriptional response is completely different when they're infected with coronaviruses. If you want to know why this is happening, I've got a couple of ideas on poster number 15. Thank you very much. Sounds like bingo.